In C02, you built an ALV report using the functional API. You passed structures and internal tables into a function module, registered callbacks as strings, and used C41 to create toolbar buttons. It works, but it has friction. The functional API was designed in the late 1990s, before ABAP had first-class object orientation. The API CL_SALV_table was designed to replace it, and it is cleaner at every level. No string-named callbacks. No separate toolbar transaction. Method calls, event handlers, and object composition all the way through. This module covers CL_SALV_table, the slight standard for all new ALV development. By the end of this module, you will be able to call CL_SALV_table equals factory to create a full-screen ALV, configure columns using method calls on the returned column objects, add aggregations and sorts with subtotals, configure display and functional settings, handle the added underscore function and link underscore click events using setHandler, add custom toolbar buttons in pure ABAP code, and embed an ALV inside a DinPro screen container using CL_SALV_. Module 01 covers the ALV foundations, the factory call and object hierarchy, column configuration, aggregations and sorts, and display and functional settings. Each topic uses the same pattern: one root ALV object, a subobject per concern, and method calls instead of fieldcat flags. Everything starts with the factory class method. You call CL_SALV_table equals factory, passing your data table as a changing parameter and receiving the ALV object back via the importing parameter r_salv_table. Always wrap this in try/catch for CX_SALV_MSG. If factory fails, you want a meaningful error message, not a dump. The returned object low_salv is your entry point to the entire ALV configuration. Every feature is accessed by calling a getter method that returns a configuration subobject. Get_columns returns the column configuration object. Get_aggregations returns the aggregations object. Get_sorts returns sorting and subtotals. Get_display_settings controls visual behavior like zebra rows and the header. Get_functions manages the toolbar. And Get_events gives you the event object you register handlers against. This hierarchy, one root object, subobjects for each concern, is the core design of the API. After all configuration is done, you call low_salv-display, and the grid appears. For a data refresh without redisplaying the whole screen, you call low_salv-refresh. Column configuration is done through the CL_SALV_columns_table object returned by get_columns. Call set_optimize passing ABAP_true to auto-size all columns to their content. Then configure individual columns by calling get_column with the field name. Cast the result to CL_SALV_column_table using the cast operator. On each column object, you can set the short, medium, and long text. These appear as column headings at different screen widths. Set output_length for the column width. Call set_key passing ABAP_true to mark a key column. Call set_visible passing ABAP_false to hide a column from the initial display. The user can still show it from the column chooser. Call set_technical to hide a column permanently, even from the user. For clickable link cells, call set_cell_type passing the constant if_cell_type equals hotspot. This makes the cell a clickable link that fires the link_click event when clicked. Always wrap individual column access in try/catch for CX_SALV_nut_found. If the field name is misspelled or the column does not exist, you get a clean exception rather than a dump. To add a column total, call get_aggregations, then add _aggregation with the column name and aggregation type. The constants are in the interface if_salv_c_aggregation. Total for a sum, minimum, maximum, average, and count. Wrap in try/catch for CX_SALV_data_error. This fires if the column type is incompatible with the aggregation. For sorting, call get_sorts, then add _sort with the column name, position, order. Using if_salv_order equals ascending or descending, and optionally subtotal set to ABAP_true. Setting subtotal to ABAP_true on a sort column inserts a subtotal row whenever that column's value changes. Combined with an aggregation on a numeric column, this gives you exactly the same vendor group subtotals you built in C02, but with cleaner code and no fieldcat flags to remember. Notice that in the OO API there is no equivalent of the functional API's no_total in layout flag. When you add an aggregation, the grand total row appears automatically at the bottom. Display settings are accessed via get_display_settings. Call set_striped_pattern with ABAP_true for zebra rows. Call set_list_header with a string for the report title shown above the grid. Call set_horizontal_lines and set_vertical_lines to show or hide grid lines between rows and columns. For row selection behavior, call get_selections and then set_selection_mode using one of the constants from if_self_selection_mode. None, single, multiple, row_column, or cell. Multiple allows the user to select several rows for bulk processing. Row_column allows both a full row click and an individual cell click. To enable interactive column sorting by clicking the column header, call get_functional_settings, and then set_sort_header_click with ABAP_true. Module 02 builds on the OO foundation. Event handling with set handler, custom toolbar buttons in pure ABAP, row coloring, and embedding an ALV into a DIN-Pro screen with CL_SA_ALV_grid. Each topic uses the same configuration subobject pattern from Module 01. Get a subobject from the root low_salve, then call configuration methods on it. Event handling in the OO API is done through a local event handler class. The pattern is: define a local class with methods that handle specific events, then use setHandler to wire those methods to the event object returned by get_events. The added underscore function event fires when the user clicks a toolbar button, either a standard SAP button or a custom button you added. The event parameter _salve_ function contains the function code. Use a case statement on this parameter, exactly as in the C02 user_command callback, but now it is a proper method in a class. The link_click event fires when a user clicks a hotspot cell. The event parameters row and column give you the row index and column name. Use red table with index row to get the full data row. Then use it however you need, typically to fetch and display detail data. After processing an added_ function, if you have changed the data table, call low_salve-refresh to update the grid display. In the functional API, this required setting rs_cell_field refresh. In the OO API, it is a single direct method call. Adding custom toolbar buttons requires no SE41 session. It is done entirely in ABAP. Call get_functions to get the functions list object. Call set_all with ABAP_true to enable all standard SAP toolbar buttons: sort, filter, export to Excel, layout variants, and print. Or selectively enable groups using individual set methods. To add a custom button, call add_function with 4 key parameters. Name is the function code that appears in _salve_ function when clicked. Icon is an SAP icon code. Text is the button label visible in text-only mode, and tooltip is the hover text. The position parameter controls placement using the constants in if_salve_c_function_position. Wrap add_function in try/catch for cx_salv_existing_object. If the function code is already registered, this exception fires. It is not fatal, just catch and continue. Row coloring in the OO API works through a color column in your output table, just as in C02. Add a field of type LVC__skal to your type structure. Populate the color table for each row while building the output, setting the name field for cell level coloring or leaving it empty for whole row coloring, color call for the color number 1 through 7, and colorant for intensity. Then call set_color_column on the columns object to register the field name. The same constant set you used in the functional API applies. Color numbers map directly to the standard SAP palette, so a row marked color call equals 3 renders in the same yellow as it would have under the functional API. For embedding an ALV inside a DIN-Pro screen, Use CL_SALV_grid instead of CL_SALV_table. The factory call takes an additional R_container parameter. You pass an instance of CL_GUI_custom_container bound to a custom control element on your screen. After display, refresh the embedded grid by calling low_grid-refresh. The configuration API is identical to CL_SALV_table. Same method names, same event registration, same aggregations. The 4 CL_SALV_ variants give you the full range. CL_SALV_table for full screen lists, CL_SALV_grid for embedded screens, CL_SALV_grid for hierarchical data, and CL_SALV_table for header item style reports. The comparison summarizes the key differences. Every aspect of the OAPI is cleaner: columns via object methods instead of a flat table, events via set handler instead of string-named forms, custom buttons in pure ABAP instead of C41, refresh via a method call instead of setting a field in a callback parameter. The OAPI also supports embedded ALV, which the functional API cannot do. And it is more testable because classes can be injected via interfaces. Slight standard: CL_SALV_table for all new development. The functional API is legacy. Maintain it when you find it, but never choose it for new code. CL_SALV_table equals factory returns your ALV object. Configure it via a hierarchy of subobjects. Get_columns for column settings, get_aggregations for totals, get_sorts for sorting and subtotals, get_display_ settings for zebra and header, get_functions for toolbar buttons, get_events for event wiring. Set handler registers your local event handler class methods against the event object. Add_function adds custom toolbar buttons without C41. Low_salve-refresh updates the display. For embedded ALV on a DINPro screen, use CL_SALV_grid with a container. Your lab rebuilds the Acme PO ALV report from C02 using CL_SALV_table, same data, same features, cleaner code. When complete, you will have a side-by-side comparison of both approaches. Good luck, and I will see you in C04, Smart Forms and Adobe Forms.